sincere thanks for Professor Devashish Bhattacharya, who is the chair professor of the A.K. Gun Center at Shanti Niketan. And he is a good friend of mine, and also we have worked very closely together for the last 3-4 years and conducted many workshops at Shanti Niketan. And I was a regular visitor to Shanti Niketan from 2017, 18, 19, 20, 4 years continuously. Anyhow, today's topic, which have been assigned to me, is about univariate and bivariate statistical techniques. And as far as univariate techniques are concerned, you will see some of its part is basically devoted to the research methodology part, which I'll be covering. And the second part, which is bivariate, is covering the correlation and regression. And tomorrow I will cover the multiple correlation, problems in multiple correlation, and also another topic which have been assigned is about factor analysis. So I have conducted nearly more than 100 workshops on SPSS, and if you have any problem on SPSS, you can ask me. I also conduct many workshops on R using RStudio, as well as MOS, analysis of movement structure, and Minitab, Stat Graphics, MATLAB. So conducting many workshops on these softwares too. So let me share the presentation, and we'll start without wasting any time. Okay. Can you see my desktop now? Is it visible? Desktop is visible? Okay.
Yes, sir.
One person maybe unmute so that I can, if I ask some questions, maybe he or she can answer, please. One person. Otherwise, if everybody start answering, I'll give you a time to answer the questions in between. I mean, to answer. So don't worry at all. So I will start from very basics, and then we'll try to build up some advanced topics. As you know, this is a national workshop on research methodology in social sciences, and most of the social sciences, they do research using the software which is called SPSS. And people even don't know sometimes what is the meaning of SPSS. People call it Statistical Package for Social Sciences. Actually, absolutely wrong. It's not. Its name is not Statistical Package for Social Sciences, please. You can note down the actual name of SPSS. Its actual name is Statistical Product and Service Solutions. That is the real name of SPSS. Statistical Product and Service Solutions. That is the real name of SPSS. And what happens in 2011, the SPSS, the entire SPSS has been procured by IBM. And now it is no longer even called Statistical Product for Service Solutions, which is the abbreviated form for SPSS. It is basically now called IBM SPSS Statistics Package. So if you want to refer to this package, please write down IBM SPSS Statistics Package. Version may be your 23, 24, 20, 26. So 27th version is also available. So there are different versions, and they are trying to modify from each version to versions. So this part is basically concerned with very basics, univariate and bivariate analysis, and I'll give you some idea about SPSS, how to enter the data, how to label, how to import files, how to split files, how to select cases. All these things will be discussed, and then univariate analysis. So what will be there in univariate analysis, I will discuss in detail. And in bivariate analysis, we will do all correlation and regression part. Today, we will carry out only the simple regression, and tomorrow we'll move on to multiple regression as well as factor analysis. Let me take the session up to 7 o'clock. Then we have a break for 5-6 minutes, and you can ask questions from me. Am I audible clearly, or is there any problem?
Sorry. Yes, sir. Clear.
Okay. All right. So let me start with to do any kind of research. The important part is to look at or to understand the nature and types of data. Unless otherwise you are not familiar with the nature and types of data, it is difficult to carry out any type of research in statistics. So if you look at the nature of data, any type of data, either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where features can be easily extracted. For example, if I give you height of 20 students, then you can compute its mean, you can compute variance, you can look at the minimum value, maximum value, range. Then you can also compute quartiles, you can compute percentiles, you can look at the skewness, you can look at the kurtosis. So if there are, let's say 20 or 100 observations, you can easily work out many features. So this comes under, this is what we mean by structured data. So in structured data, features can be easily extracted, like mean, median, mode, skewness, kurtosis, etc. And most of the time, the structured data is in the numeric form. But what happens sometimes, the data is not in the numeric form, but you can easily convert your data into numeric form. For example, gender. Now, gender is not numeric as such. It's male and female. But I can always assign certain codes, say male as 1, female as 2. And then you can go for counting. How many times 1 has appeared in your data? How many times 2 has appeared? 1 means male, 2 means female. Similarly, religion. I can write Christian as 1, Hindu as 2, Muslim as 6, or you can write Sikh as 1, Muslim as 2, Hindu as 3. Doesn't make any difference, right? All these are categorical data, but you can still go for the counting. How many Hindus are there? How many Muslims are there? So it becomes easier to extract features out of this data. Similarly, rural and urban, I can code this as 1 and 2, right? So what do you mean by structured data? Structured data is the one if it is already in the numeric form, or you can easily convert your data into numeric form to extract certain kind of features. That also comes under structured data. Hopefully the term of the structured data is clear to you. Then we have unstructured data. Now, what do you mean by unstructured data? Unstructured data is the one where the features are not easy to extract. For example, everybody is using WhatsApp. You are receiving thousands of messages every day. There are videos, there are pictures, lot of information is there. But if at the end of the day, I ask each and every one of you to convert this entire information into numeric form, I don't think it's easy. But information is there. Obviously, this kind of data, which is not in the numeric form, and it is not easily convertible into numeric form, comes under what is called unstructured data, right? You look at any social media site, Facebook, Twitter, or you even look at the email, there is a lot of information, but it is not possible to convert this kind of information into numeric form very easily. So this is what we mean by unstructured data. And two of my students from bioinformatics, two from statistics, they have done their PhD on unstructured data. So we have derived certain mechanisms using machine learning tools, using artificial intelligence and statistical tools, and also using the application of Dirichlet's integral, where without reading the text, you will come to know what they are talking about. If there is a research paper, you will not have to go through the research paper. Without reading the research paper, we can come to know what they are talking about. So that is the application of this unstructured data. It's easier to deal with structured data, very difficult to deal with unstructured data. But as far as this course is concerned, we will focus only on structured data. Hopefully the term structured data is clear, which is mean if it is in the numeric form. And people also talk about these days about big data. Big data is nothing but a combination of structured and unstructured data. Some part may be structured, which is in the numeric form. Some may be unstructured, which is in the textual form, right? So that is all about the nature of the data. But we will be talking about structured data. And if you look at the structured data, it is basically of two types. Any type of structured data, either it is called categorical data or it's called measurement data. Now, what do you mean by categorical data? Categorical data is the one where measurements are in terms of categories. For example, I have already given you an example of a gender. I can write male as 1, female as 2. So it's basically a category. Similarly, religion, I can write Hindu as 1, Muslim as 2, Sikh as 3, Christian as 4, or you can write in any other order. Different colors can be coded. Socioeconomic class can be written as lower class, middle class, upper class, 1, 2, 3, right? So if you're able to assign these labels some kind of codes like 1, 2, 3, etc., then this comes under what is called the categorical data. And what's a measurement data? Measurement data means some kind of instrument is being involved in measuring something. For example, you can measure height, you can measure weight, blood pressure, cholesterol, skin fold thickness, chest measurement. And sometimes you don't require any instrument, but it could be a measurable quantity. For example, to measure age, you don't require an instrument, but age can be measured in years, you can add months, even days, minutes, and seconds. So it becomes a measurable quantity. So hopefully the term categorical data and the measurable data, they are clear to you. But we will give you certain more examples. These are the examples of the categorical data. For example, hair color. Hair color could be brown, it could be red, it could be black. I didn't put a white there because people sometimes get depressed, particularly in COVID era. Our entire body is made up of 4 types of nucleotides, and the entire genetic research, people are talking about 3 mutants now. The first mutant and now that it is 3 mutants, the COVID problem. These mutants are happening because of these nucleotides. A comes with T, G comes with C. So if they mutate, that means if G comes after G or T comes after C, then there is a mutant. So there are 3 mutants now, the COVID, new COVID, which has entered in India, and it has taken a lot of lives. You see, the entire research is going around these, the research of the nucleotides, basically. And you see, I can write A as 1, T as 2, G as 3, C as 4. It can be categorized. Similarly, eye color can be written as 1, 2, 3, like 1 is black, 2 is brown, green, 3, blue, 4. Gender can be written as 1 and 2. Then disease can be mild, moderate, severe, 1, 2, 3. And genotypes, depending upon which one is heterogeneous, which one is homogeneous. So you can write 0, 1, and 2. If it is small hh, you can write 0. If it is capital H, small h, you can write 1. If both of them are dominant, capital H, you can write 2. So these are genotypes. So all these are examples of the categorical data, where once you write, then you can extract how many people are of brown color, red color, how many people, how many males, females are there. So features can be easily extracted. These are the examples of measurement data. I don't need to explain anything, right? Height, weight, blood pressure, cholesterol. Similarly, FPKM value. Basically, whenever we convert this entire nucleotide information, which is in terms of ATGC, so there is a quantification to ATGC, and that quantification value is called FPKM value, and FPKM value stands for fragment per kilogram per million. Fragment per kilogram per million, right? Similarly, number of expressed genes for a particular disease, how many genes are expressed, time to complete a homework assignment, time is also a measurement. Now, if you look at the measurable data, many type of measurable data, either it is called continuous or it is called discrete. Now, what do you mean by discrete? Discrete means if certain isolated values are present in your data, then it is called a discrete measurement data. For example, number of members in a family. There may be 5 members, 6 members, 2 members. I cannot say number of members in a family is 3.9. It doesn't make any sense. Number of errors in the book, number of students present in the class, right? So all these are examples of discrete measurement data, which can take only complete integers. And what is continuous? Continuous means it is capable of taking all values within certain specified range. For example, height. If I fix 2 and say between 145 to 170 centimeter, then height can take any value. Height could be 157.5. It could be 157.56 centimeter. You can add third, fourth decimal depending upon the accuracy of your instrument. That is called a continuous measurement. So hopefully that is difference between discrete and continuous measurement is clear. Okay, now knowledge about these scales is very important. I just discussed that there is a categorical data, there is a measurable data, and there are 2 scales for categorical data and 2 different scales for measurement data. Why I'm discussing these scales? Because if you enter any data in SPSS, it will ask you whether your data is on nominal scale, ordinal scale, interval scale, ratio scale. And if you have no clarity about these scales, you will face difficulty even in entering the data in SPSS. And you can make wrong analysis, right? So please remember there are 2 scales for categorical data. You can remember nominal and ordinal. These 2 scales for categorical measurement. Which one? Interval and ratio. I'll explain you with examples. First of all, categorical data. 2 scales, nominal and ordinal. Okay, let's look at the nominal scale for categorical data. A type of categorical data in which objects fall into unordered categories. What does this mean? That means you cannot order them, that this is smallest and this is highest. For example, look at gender, male and female. I can write male as 1, female as 2. Or you can write female as 1, male as 2, does not make any difference. You cannot order that this is lowest and this is highest. Everybody is human being, everybody is equal. And you can go through the last line to make it more clear. There is no preference of one category over the other. Bottom line is, if each and every category is given equal weightage, then we say that our data belongs to the nominal scale. As simple as that. Examples of nominal scale: what is your gender, what is your hair, so all these are examples of the nominal scale. Then comes the ordinal scale. I'll be a little bit fast because this is a very simple topic. Ordinal scale. Ordinal scale is also for categorical data, and the difference between nominal and ordinal is that, as the name suggests, ordinal, that means you can order the categories. A type of categorical data in which order becomes important, and you can arrange the categories either in ascending or descending order of magnitude, right? For example, socioeconomic class: lower class, middle class, upper class. So lower means the lower income group, upper means the higher income group. So I can arrange the categories in order 1, 2, 3. 1 means the lowest, 3 means the highest, right? Similarly, age categories. If you look at age categories, then age can be divided into different categories. Say 20 to 30 years, 30 to 40 years, 40 to 50 years, 50 to 60 years, 60 to 70, and 70 to 80 years. 1, 2, 3, 4, right up to 8. But these categories can be arranged in order from the lowest to the highest. Education categories can be arranged in order: primary school, middle school, high school. So all this type of data which can be arranged either in ascending or descending order of magnitude, but it is categorical, right? That comes under what is called the ordinal scale. But please remember the last line. The numerical distance, whether you are talking about the nominal scale, whether you are talking about the ordinal scale, numerical distance between any two categories or between the categories does not have any significance. For example, if I write down male as 1, female as 2, and subtract 2 minus 1, it doesn't have any meaning. If socioeconomic class, lower class as 1, middle class as 2, upper class as 3, 3 minus 2 or 3 minus 1 does not have any meaning. Ordinal and nominal scale, they belong to the categorical data, and here are the examples of ordinal scale. How do you feel today? This is the second lecture. You may be a little bit tired, so I can imagine where do you stand. But for the time being, you can rate yourself: very unhappy, unhappy, okay, happy, very happy. And how satisfied are you with our services? So this will I maybe ask you tomorrow after the entire workshop, after the entire my session. I mean, very unsatisfied to very satisfied. The idea here is that you can arrange the categories in order. Very unhappy means the lowest category. Very happy means the highest category. So you can arrange the categories in order. Very unsatisfied, lowest; very satisfied, highest. So you can arrange the categories in order. So all this, if you are measuring your data on 5-point scale or a semantic scale, 7-point scale, or a 10-point scale, you can very well imagine your data is on ordinal scale. Okay, that's all about the categorical data. Now we look at the measurement data. Measurement data also having two different scales, interval and ratio. And people get confused between interval and ratio. In interval scale, look at the first line. In interval scale, mathematical operations may not be valid. There are many types of data where mathematical operations are not valid. Let me give you an example. Let's say some beauty contest is going on, and there are judges, say, giving score out of 10. Let's say first person gets a score of 8 out of 10, and second one gets a score of 4 out of 10. Now, if you divide 8 by 4, answer will be 2. But you cannot make a statement that the person whose score is 8 is exactly twice the beautiful than the person whose score is 4. You cannot make such type of statement. Let's say one student has scored 90 marks in a test. Another student has scored 30 marks in a test. Divide 90 by 30. Answer is 3. But I cannot make a statement that the student whose score is 90 is exactly 3 times the intelligent than the student whose score is 30. I cannot make such type of statement, right? So mathematical operations may not be valid, like beauty score, intelligence score. And in interval scale, 0 is always has a meaning. That's why in interval scale, 0 is called the arbitrary 0. Arbitrary 0. For example, if I say temperature 0, it does not mean the temperature is absent. It is still better than -5. If I say somebody has scored 0 in a test and the person is not intelligent at all, No, this is not true. Maybe on a particular day, his or her performance is not up to the mark. Next time, he or she can score better. So 0 does not mean the absence of character. 0 does not mean the absence of character. That means 0 has a meaning for you. If 0 has a meaning for you, your data will go to the interval scale. As simple as that. If 0 doesn't have any meaning, your data will go to the ratio scale. Right? So just look at 0 for your variable. If 0 has a meaning, data will go to interval. If 0 doesn't have any meaning for your data, it will go to the ratio scale. So I'll come to the ratio scale now. Now, ratio scale, all mathematical operations are valid. But you have to be careful about 0. Here, 0 is called the true 0. For example, if one person is having weight 90 kg, another person is having weight 45 kg, divide 90 by 45, answer is 2. But you can always make a statement that the person whose weight is 90 kg is double the weight of the person whose weight is 45. Nothing wrong with that. It's double. You can always say that the age of the father is 3 times the age of the son. If son is 15 years, father is 45 years. So it's 3 times. Nothing wrong with that. But look at 0. If I say height 0, it doesn't have any meaning. If I say age 0, it doesn't have meaning. If I say weight 0, it doesn't have any meaning. So that's why in ratio scale, 0 is called the true 0. While in interval scale, 0 becomes arbitrary 0. Please remember these things. And let's look at the summary of different type of scales. Here I have put in all the 4 scales: nominal, ordinal, interval, and ratio. The first 2 scales are for categorical data. The next are for measurable quantities or measurable data. Generally, we are involved in counting, and counting is possible in all the 4 scales. You can count how many males, how many females are there. You can count how many people belong to the lower class, middle class, upper class. Similarly, in interval and ratio, you can divide the data into small intervals. Go for counting. How many people belong to 10 to 20, how many people belong to 20 to 30, and so on. So counting is possible. But generally, how do we compute median? We compute median when we arrange the data in increasing order or decreasing order, and then look at the middlemost value. But do you think it is possible to arrange the data in order in nominal scale? Not at all. So it doesn't make any sense in nominal scale. But it makes sense in ordinal scale because you can arrange the categories in order and then look for the middlemost category. In interval scale, you can arrange the data. In ratio scale, you can arrange the data. Order of the values. Order of the values means it is lowest, it is highest. So that is not possible in nominal, but it is possible in ordinal, interval, and ratio. Can quantify the difference. Difference, etc. I have already explained. It does not make any sense in nominal as well as ordinal, but it makes sense in interval and ratio. Can add or subtract only in interval and ratio. Can multiply or divide only in ratio, and have a true 0 only in ratio. So please remember these things so that this is summary of different kind of scales. Hopefully all these scales are clear, and they have to be clear because we have to start with SPSS. Now this is something important. We deal with the same kind of variable and it can be put into different scales. For example, let's look at education as a variable. Some of you participants may be from education. Now, education can be measured from different point of view. Now, this variable education can be put on a nominal scale when measured the education variable in terms of a type of education, such as private or public. Some people prefer private education, some prefer public education. So it is individual choice. So your data will go to the nominal scale, and it becomes ordinal when measured by the level of education, such as primary school, high school, college, graduate, postgraduate. So you can arrange the categories in order. And what is variable? Variable is again education. So education can be put into nominal, education can be put into ordinal, depending upon how you measure the variable. It could be type of education, it could be level of education. And if you go to US or any other country, they will ask you about the number of years of education. 10 years of education, 20 years of education, 15 years of education. And the same variable can go to the interval scale. So question very important, same variable can be put into different scales. Question is, how do you measure? That's the most important part. Why I discuss about these scales? Because entire statistical analysis depends upon the knowledge of these scales, right? Now, if you are dealing with the categorical data, then the statistical analysis is totally different. For example, if there is a categorical data and somebody asks you to compute correlation, etc., you cannot go for Karl Pearson's, Spearman's type of correlation. There are different type of correlations for categorical data, which I will discuss, right, in today's session. And if you're dealing with the measurement kind of data, then there are different statistical techniques. For example, you can compute mean, you can compute standard deviation, quartile deviation, mean deviation, right? Skewness, kurtosis for measurable quantities. They are not possible for categorical data. Problem comes whenever some part is categorical, some part is measurable quantities. For example, if somebody asks you a question, is there any association of blood pressure with gender? Now it's a big problem. Gender is categorical, male and female. Blood pressure is a continuous measurable. So what you will do? So I will discuss all these techniques. So please remember, if there is a categorical data, techniques are different. If there is a measurable data, techniques are different. And if the mixture of the two, again, statistical techniques are very well defined. Okay. Now, when people deal with the categorical type of data, they generally compute percentages or proportions, right? Percentages or proportions. Or sometimes people also draw a bar diagram or chart, pie charts, etc. Please remember, there is a difference between diagram and graph. Diagrams, charts, etc., they are always for categorical data. While histogram, box plot, they are for continuous data. You can note down, please, certain things, right? There is a difference between diagram and what is the difference between diagram and graph? If there is x-axis, there is a y-axis. If there is no proper scale on x-axis or y-axis, then it is a diagram. But if there is a proper scale on x-axis, proper scale on y-axis, then it is called a graph. For example, look at the bar diagram of male and female. Let's say there will be two bars. On x-axis, I have a male and I have a female. Percentage of male is say 40%, percentage of female is 60%. So two bars. But what is the scale on x-axis? There is no scale on x-axis. Only category, male and female. So that means it is a diagram. If I am plotting height and weight, height on x-axis, weight on y-axis, then there is a proper scale for height, proper scale for weight, then it is a graph. Remember, please. Okay. And for categorical data, generally we have pie diagram or pie chart or bar diagram, etc. Okay. But look at the last paragraph. In fact, one can perform all type of statistical analysis. Today, I will show you how to compute different type of correlations even for categorical data. Right? Correlations like tetra correlation, biserial correlation, point biserial correlation, gamma coefficient, coefficient of uncertainty, Matthews correlation coefficient. All these coefficients are there whenever we deal with the categorical data. And one of my Iranian student, Azad Roshani, he has completed his PhD on categorical data only, right? And we have derived certain new methodology techniques to do different type of correlations whenever there is only categorical data. And there are different regression techniques for categorical data, like logit regression, probit regression, top-bit regression, logistic regression. So these are the different kind of regressions which can capture your categorical data. Generally, linear regression, simple regression, multiple regression, which I'll be discussing today and tomorrow, they are for measurable quantities, measurable data. But if there is a categorical data, you want to include that, then you cannot include those into those type of models. Similarly, in different type of statistical modelings for categorical data, like people are aware of one-way analysis variance, two-way analysis variance, but they are for measurable data. But if your data is categorical, then there are different type of techniques. For one-way ANOVA, there is a Kruskal-Wallis test. For two-way ANOVA, there is a Friedman test, if you're dealing with categorical data. So there are many techniques. Okay, and when people deal with the measurable quantities, measurable type of data, then there are a lot of choices. You can compute mean, you can compute standard deviation, you can draw histogram, you can draw a box plot, and you have already done this part. In fact, one can perform all type of parametric and non-parametric procedures depending upon the measurement data. Question is, if your data satisfies certain set of assumptions like independence, normality, etc., then you apply parametric test. If they are not satisfied by your data, then we have to go for the non-parametric test. Okay. Now, before coming to the SPSS, So I'll just discuss about in 5-10 minutes the descriptive statistics. I'll not give you any formula, promise, but just give you some idea where to use these descriptive measures and why they are important, and which one is applicable where. Right? Let's say I take a simple. What do you mean by descriptive statistics? Descriptive means you are trying to describe the features of your data, basically. That's why the name comes descriptive. And sometimes people also call this as summary statistics. They are used in vice versa. Sometimes people use summary, sometimes people use descriptive statistics. Okay. All right. Now, if I give you a basket of, and I ask you to comment something on this. So somebody can comment on the shape and size, that some are small size, some are bigger size, some are medium size. Somebody can also look at the different colors. Somebody are some oranges are more yellow, some are still they are green, some of them are in between. So what you are trying to do basically, you are trying to describe the features. But this is just 100 oranges. Suppose I give you 50 lakh observations. Suppose I give you 5,000 observations. So how to describe your data? You cannot describe in terms of only size or the shapes, etc. You need some mathematical measure or the statistical measures. That's why center tendency comes into the picture. For example, if I give you 20 observation, I ask you to compute mean. So you will compute mean. How do we compute mean? Let's say I give you a population data from 1981 to 1990, 10 years data, 1981 to 1990. All the figures are available for population. I ask you to compute mean. You add all the 10 figures, divide by 10, you will get mean, right? But one problem. Let's say 88 population, there is a question mark, the population is missing. And I ask you to compute mean. 1981 to 1990, 88 population is missing. I ask you to compute mean. Now you are in a fix because one observation is missing. You can compute mean of 9 observation, but I am asking mean of 10. Not possible unless you apply some estimation procedure. So there are certain problems with mean if there are missing data, right? Another problem of mean is, let's say most of the observations, say they are between 100 and 120, between 100 and 120, most of the observations. So if you compute mean will come out somewhere between say 110 or 112, or depending upon the observations, it may be 114, 15, or it may be at 106, but definitely it will be between 100 to 120. But suppose there is one observation which is 210. Now you include this observation also into computation of mean. Because of one observation, your entire mean may be shifted to 160, while 99% of the observation, they are between 100 to 120. Do you think mean is a right representation? If your report the value 160 is correct, I don't think so. It is not representing the entire set of data. So mean has a certain problems if there are outliers present in the data, if there are missing values present in the data. That's why median comes into picture. Because if you look at the population data, 88 population is missing, but I can assume that population is most of the time increasing, and 88 population will be higher than 87. 89 will be higher than 88. You can always make such type of assumptions. And if you arrange the data in order from 1981 to 1990 and look at the, rather than computing mean, now look at the median. Median will be somewhere around 85, right? So median makes sense, but mean does not make sense. Similarly, in the, if there are observations between 120 and 100, and you arrange the data in order, one observation is 210, doesn't matter. But look at the median. Median will be somewhere between 100 to 120. So median makes sense, but not mean. So that's why there is importance of median. I'll not give you any formula, right? Of course, this is the formula for computing mean, sum of all the observation divided by number of observations. And depending upon odd and even, you can compute median. I'll not go for this. Look at the mod. What is mod? Please look at the first line. The most frequently occurring values among the set of observations is called mod. Let me just repeat. The most frequently occurring values among the set of observations is called mod. Look at the simple data. 1, 5, 4, 5, 5, 5, 7, 3, 5, 2. So you can easily see 5 is repeated maximum number of times. 5, 3 here, 1 here, and 1 here. 5 is repeated 5 times. So basically 5 is the most frequently occurring value. So mod will be 5. But suppose I change this data a little bit. Suppose 5 is occurring how many times? 5 times. I change this data. Suppose 7 is also occurring 5 times. Now there are two values. 5 is occurring 5 times. 7 is occurring 5 times. And I ask you to compute mod. Somebody can answer that mod will be 5 plus 7 divided by 2. Answer is 6. Absolutely wrong. Why? Look at the definition. The most frequently occurring value. The most frequently occurring value. Now there is no most frequently occurring value 6. So 6 cannot be mod. Remember, please. What could be the value of mod then? Now there are two mods basically, because 5 is occurring most of the time, and 5 is occurring most of the time, and 7 is also occurring the equal number of times. So there are two mods. 5 and 7, both of them are considered to be mod. 5 and 7, both of them are considered to be mod. Okay? And let me change this data a little bit again. Suppose every value is occurring once. 1 is once, 5 is once, 4 is once, 7, 3, 2, 1. Every value is occurring once. And I ask you, what is the mod? Somebody can answer that all the values can be considered as mod. Absolutely wrong again. Because look at the definition. The most frequently. There is no most frequently occurring value. So mod will not exist. That is the correct answer. Right? So please remember, mean is having one value, median is having one value, but mod may have two values. Mod is not unique. If there are two values in your data for mod, this is called bimodal distribution. If there are three mods, this is called trimodal distribution. And trimodal and tetramodal, etc., they are known as multimodal distributions. Right? Okay. And mod may not even exist. Okay. Now, once we know mean, median, mod, then why to look at dispersion or variation, right? I have started from very basics so that I can give you certain logics which are not given in any book. And then I'll come to some other topics like correlation and regression in the second part of my lecture. So measures of dispersion. As I mentioned, if you know mean, median, mod, then why to look at dispersion? Let's look at series 1 data and series 2 data. Please try to understand these things are very important. Here, series 1 data, you can see 1, 5, 9, 13, 17. Series 2 data we have. If you take the sum of this, sum will come out to be 45. Take the sum of these values, sum is again 45. And how many observations are here? 5. How many observations are here? 5. How do we compute mean? Sum divided by the number. Mean will be 9, mean will be 9. Okay. Now, I'll not show you the data. Suppose I'll not show you the data. I simply ask you one question. That mean of 5 observation is 9. Can you make out whether this is data series 1 or series 2 data? It could be series 1. It could be series 2. So what is the meaning of this? That means mean is not describing your data completely. There is something missing. And that missing part is basically called variation or variability. Right? If you look at series 1 data, it varies from 1 to 17. 1 to 17, very large variation. But look at series 2 data, it's very, very close. 7 to 11, very, very close. So series 1 data obviously is having more variation as compared to series 2. But there are only 5 observations I can see from my eye. But suppose there are 50,000 observations or 5,000 observations. Then can you see from your eye? It's not possible. That's why we look at some kind of mathematical measure. Simplest mathematical measure is range. You look at the range. Range is the difference between highest and lowest value. 17 minus 1, 16. In second case, 11 minus 7. So where the range will be less, the dispersion will be less, or variation will be less. Where the range will be high, it will be more. But range is not a very good measure of dispersion. Look at the data which I was giving you the demonstration between 100 and 120. Suppose all values are between 100 and 120. Then what will be your range? 120 minus 100, it will be 20. But suppose one value is 210. Now look at range. Your range will be 210 minus 100. It will go up to 110, which has no meaning. So range is not a very good measure of dispersion or variation. Then what is the best measure of dispersion? Best measure of dispersion is either called standard deviation or it is called variance. If you take the under root of variance, it becomes standard deviation. I'll give you the logic why we take under root. But why variance is considered to be the best measure in mathematical form. And if you have 5,000 observation, if you have 50 lakh observation, doesn't matter. Variance is considered to be the best measure of dispersion. Why? Let me give you the logic. Look at the series 1 data. It's a series 1 data and series 2 data. Same data I'm considering. Right? Now, our central point is mean. Mean is placed at 9. You can see mean 9 is there in the center in both the series. Let's say I subtract center from each observation. What will happen? So, any observation in, please remember the notation, any observation in statistics is denoted by xi. Mean is denoted by x bar. For example, in series 1 data, x1 will be 1, x2 will be 5, and the last x5 will be 17. Similarly, in series 2 data, your x1 will be 7, x2 will be 8, and so on. So hopefully the notation is clear. Let's look at this part, xi minus x bar. Here I have written xi minus x bar. Your x bar is 9. These are all xi values. So 1 minus 9, you subtract, minus 8. 5 minus 9, minus 4. Next will be 0, next will be 4, next will be 8. Similarly, in second series, you have 7 minus 9, minus 2, 8 minus 9, minus 1, 0. Right? The one thing should be clear. Now everything is 0 is in the center, and it's easier to make comparison in terms of 0. Let me go through this diagram, next one. Look at this diagram. Comparison in terms of 0. So this was series 1 and this is series 2. Series 2 variation is only from minus 2 to 2. You see, it is from minus 2 to 2 and 0 is there in the center. What is series 1? Varies from minus 8 to 8. 0 is in the center. You see, minus 8 to plus 8. So easily you can see that series 1 is having more variation from here to here, while series 2 is having less variation. Hopefully the diagram, it is clear. That's why we subtracted mean, because if your values are closer to 0, all differences are closer to 0, variation will be less. If they move far away from 0, variation will be more. As simple as that. But in social sciences people, in medical sciences people are afraid of the negative sign. They don't want to include negative sign. Then statistics people are very smart. They say, why? Okay, let's take this as positive. So how to make a negative as positive? Take the square. So we have taken the square, xi minus x bar square. So if you take the square, minus 8 square will be 64, minus 4 square will be 16, and so on. Similarly here also, this will become 4, this is this and this. But nothing has happened. Negative values have become positive. Nothing has happened. But suppose I take a sum of these squares. I take a sum of all these values and also take the sum of this. If you take the sum, means 64 plus 64 plus 16 plus 16, it will come out to be 160. So sum of these squares will be 160. Sum of these will be this. So one thing is very clear now. Where the sum is more, the variation is more. Where the sum is less, variation is less. But luckily there are 5 observations. Suppose you have in series 1 marks of 100 students, and in series 2 you have marks of only 20 students. So obviously if there are 100 students, variation will be more. This sum will be more. And for 20 students, this sum is likely to be less. So you cannot compare the sum basically. But if you take the average, what will happen? If there are 100 students, their marks are given, you divide by 100. If there are 20 students, their marks are given, you divide by 20, average will almost be same. So we divide by n. If you divide by n, it's some sort of average of this sum of squares. So average 160 minus 5 will be 32. And here 10. 10 divided by 5 will be 2. And now you can see where this average is less, variation is less. Where this average is more, variation will be more. And what is this? You have studied the formula in your 10th class, 11th class. This is the formula for variance. Then people say that statistics people, they make very complicated formulas. It's a simple logic, right? We subtracted the mean from every observation. Then it comes negative, very difficult to deal with. Take the square, take the sum, and take the average. That's it. So where this average will be less, variation will be less. Average will be more, variation will be more. That is the logic behind variance. And it is based on all the observations. That's why variation is considered to be the best measure. Range is just based on 2 of them. So this we considered, and this is the formula for variance. And if it is a square, then we in statistics, this is called second order movement. If it becomes 3, power 3, then this is called third order movement. If it becomes power 4, then it is called fourth order movement. So variance is second order movement. Then we have third order movement, if power will be 3. Then we have fourth order movements. And these movements are helpful to look at the skewness and kurtosis of your data. Okay? All right. So I have explained you the logic behind variance, then why to look at standard deviation. If variance can give you variation of the present in the data, why to look at standard deviation then? Okay, generally in research papers, what we write? Mean plus minus standard deviation, not mean plus minus variance. Why? Because let's say we have a height of 20 students, which is given in centimeters. Then mean will also be in centimeter, because you are dividing by a constant, 20. Right? 20 students divided by 20, just a constant. So mean will be in centimeter. But what will be the variance, units of the variance? It's a square. So units of the variance will be centimeter square. You follow my point? Centimeter square. So I cannot add mean plus minus variance, because mean is in centimeter, variance is centimeter square. So I cannot add. So that's why we look at the under root. If you take the under root of centimeter square, it will come back to the centimeter. So we compute standard deviation. Standard deviation under root of variance, so that the units of mean and variance, they are same. Right? That's why. Then why to look at coefficient of variation? Coefficient of variation. You can compare using standard deviation or variance to series if they are given in the same units. Let's say one class is having 20 students and I'm just looking at height. And another class is also having 30 students. I'm looking at height only. Height is both in centimeters. You can compare using variance or standard deviation. The smaller it is, better will be result. But suppose on one side I am having height which is in centimeter. On another side, another series of data which is concerning with weight, and it is given in kg. And somebody is asking me a question whether weight is having more variation or height is having more variation. Now you are in trouble. I cannot compute variance then. That's why we look at coefficient of variation. It's a measure which is again free from the units of measurement, because sigma is measured in the same units, x bar is measured in the same units. So when we divide, they will get cancelled. Units will get cancelled. For example, I will compute coefficient of variation for height. How? Compute the standard deviation of height, compute the mean of height, divide and multiply by 100. Suppose this is coming and percentage will be given. Multiply by 100 means percentage. Let's say this percentage for height is coming out to be 57%. And same thing I do for weight. Weight in kg. So sigma will be in kg, x bar will be in kg, units will get cancelled. And suppose this variation is coming out to be 37%. So I can easily say that weight is having less variation and height is having more variation, because that is 57%, this is 37%. So please remember, whenever why to use coefficient of variation, when the series are measured in different units. Okay. All right. Now, if you divide the data into 2 equal parts, the center point is called median. If you divide the data into 4 equal parts, they are known as quartiles. If I divide the data into 10 equal parts, they are known as deciles. And if I divide the data into 100 equal parts, they are known as percentiles. And the last part, before I come on to the SPSS part, Skewness and kurtosis. Skewness and kurtosis. Why to look at skewness and kurtosis? Skewness and kurtosis help you to take a decision whether we have to apply for parametric test or we have to apply non-parametric test. If your data is almost symmetrical, there is no skewness, you apply parametric test. Otherwise, we have to go for non-parametric test. Right? Now, everybody is familiar with histogram. We look at the shape of how we draw histogram. We divide the data into small intervals, count the number of people in each interval, and then draw rectangles, which is in continuation. In bar diagram, there may be gap in between two rectangles, but in histogram, there is no gap. Let's say there is one rectangle here. There is one rectangle at the center. There are 3 rectangles on the left-hand side and 3 on the right-hand side. And if you drop a curve will look like this. And if you drop a line from the center and area on the left-hand side is same as the area on the right-hand side, then we say that there is no skewness. There is no skewness. Your data is almost symmetrical. But let's say one bar is here, bigger bar, I mean the highest bar, and there are 3 bars on the left-hand side, but there are 10 bars, small bars on the right-hand side. And if you draw a curve will look like this, right? That means if you drop a line from the center, area on the left-hand side is less, but area on the right-hand side is more. Then it is called positively skewed. And if you drop a line from here, the area on the right-hand side is less, but left-hand side becomes more. Then this is called negatively skewed. Obviously, we need some mathematical measure to compute skewness, and that is given in terms of beta 1. How do we compute beta 1? This is the formula for computing beta 1. You already know variance, but if I take the third power and add and take the average, it will give you third order moment. And then you substitute all these values here, you will get a value of beta 1. Right? Now, beta 1 could be negative, it could be positive, depending upon what is the sign of M3. Square can never be negative. M3, cube power can be negative because -1 multiplied by -1 multiplied by -1. It can 3 times, it can give you -1. But once you square this minus, because M3 square, again it will become positive. So this quantity, which is in the under root, is always positive. Then how we have to assign positive and negative sign to beta 1? So it depends upon the sign of M3. If sign of M3 is coming out to be negative, put the negative sign here in front of beta 1. And if sign of M3 is positive, assign the positive sign. This is how we measure beta 1. And simple technique is, if beta 1 is coming out to be 0 from your data, then there is no skewness in your data. You can apply parametric test. But if beta 1 is coming out to be positive or it is coming out to be negative, then we have to apply non-parametric test, right? And beta 1 greater than 0 means your data is positively skewed. So mean has shifted towards right. If beta 1 is less than 0, mean has shifted towards left. This is what it means. So it's not symmetrical. While in case of symmetrical, mean, median, mode, they are always at the same point. So this is what is called skewness and the measure of skewness. And finally, kurtosis. Kurtosis measures the pickedness of the curve. Now look at these 3 curves. If you drop a line, area on the left-hand side is same as area on the right-hand side. Similarly, drop a line. Areas are same. Similarly, drop a line. Area on the left, area on the right. But the shapes are different. Shapes are not same. Here it is very high peak. Here it is flatter peak. Here is in between. So kurtosis measures the pickedness of the curve. How high it is, how flatter it is. Right? And the measure is given in terms of beta 2. You know the 4th order moment. You know the 2nd order moment. And compute this factor. If the value of beta 2 is coming out to be 0, then your data is called a mesokurtic curve, or we call this as a normal curve, basically, right? So it is not having high peak, neither having flatter peak. But if value of beta 2 is coming out to be greater than 0, this is greater than 0, means positive, then you will say that it is having high peak. And if it is less than 0, then this is called flatter peak. And please remember, these skewness and kurtosis help us to take a decision whether to apply non-parametric test or to apply parametric test. You can note down a rule of thumb. Rule of thumb says that if value of beta 1 and beta 2, if they lies between -2 to +2, you can apply parametric test. But if they are beyond -2 or above +2, if they are below -2 or above +2, then you cannot apply parametric test. You have to apply non-parametric test. So that is the idea given by skewness and kurtosis. And here is an exercise to you. There is a line A, there is a line B. So which line seems to be smaller, A or B? So if you see from your eye, many people will say that A is smaller than B, because look at this. Look at this. Both of them are equal virtually. Both of them are equal, right? But why this was looking smaller? A was looking smaller and B was looking bigger. Because it is closed from the both sides. And this is open from the both sides. Lines are same. Life exactly works in the same way. If you see the things from the closed mind, life will be very, very small. And if you see things from the open mind, your life will be, same life will be very high and very high spirit, right? So it is all depends upon you, how you take it. It's a mathematical equation I have shown you in terms of A and B, right? Just a small exercise. Okay. All right. So it's not only we will be learning SPSS, there are many other packages like MATLAB, Minitab. Minitab is generally used for sample size calculation, power calculation. Statistica is another software which is used in data mining. Then EpiInfo is used in medical sciences, which is called epidemiological information. nQuery is used for sample size. Spss is another software, very powerful software used in multinational companies. R&R Studio, they are free softwares. And I also give training on R&R Studio. In fact, the last workshop conducted by Shanti Niketan, I was using R only. Mathematica, if you are interested in solving integral and differentiation, you can use Mathematica. Stat Graphics will give you a very, very powerful software for modeling as well as graphics. BMDP is called biomedical data processing. Then there is a Stata economics people, they use data, right, for optimization techniques, etc., or panel data regression, etc. Then SysStat is there. SysStat is also used for big data and data mining. And Spss, the refined version of Spss is now R&R Studio. Above all, now most of the youngsters, they are learning Python. And if you learn Python, because Python needs programming, and some people don't know the programming, that's why we switch on to all these packages. But if you have good hand on programming, maybe you can work with the Python, where all the features of these packages are already there. Okay, these are some of the references. If you are looking into categorical data analysis, how to do categorical data analysis, your entire data is categorical, you can go through the book by Ellen Agrasti. And if you are looking for statistical modeling, there is a book by Bowerman and O'Connell, Linear Statistical Models. And if you are looking into parametric and non-parametric statistics, there is a very good book by Wayne W. Daniel, Biostatistics. Wayne W. Daniel, W. Daniel. And if you are looking for techniques like factor analysis, cluster analysis, discriminant analysis, conjoint analysis, structure equation modeling, then this book is very good. Naresh K. Malhotra. And I read in 2019, my book was also published on medical statistics, but this is generally written for doctors. And this involves mixed modeling analysis, meta-analysis. So there are a lot of advanced bioinformatics techniques, then counting data techniques. So there are many other advanced topics are there in my book, which is called Medical Statistics by Suresh K. Sharma. So all these are references. So if you have any questions in the meantime, we have five minutes, and then we'll take a break of 5 minutes, and then I'll come back with SPSS. Please, if you have any questions, anybody is open to ask me questions. Anyone? Yes, please. Anybody can unmute and ask questions.
Sir,
yes.
I have one question. Like,
Sure.
I'm working on a research paper where I'm working on the ratios of the firms. Like, I'm working on small finance banks, and the data is the ratios of financial ratios. So,
okay,
what kind of analysis can we do on the ratios?
Yeah, you see, if you are looking for some kind of what is your dependent variable? Just tell me, what is your dependent variable? What do you want to do? Objective
Sir,
क्या
I'm
है?
just analyzing the financial performance of the banks.
But obviously you will be having certain objective, na?
Yes, sir.
What is the objective of your study?
So actually, it's a very new area, the small finance banks. So I have different categories.
Are
Basically, I'm
you
working with
comparing small and big banks or what?
No, sir. The small finance banks are a typically new category of banks introduced by RBI. So there are just 10 banks, and what I'm doing is basically I'm doing camel ratio analysis for the banks. It's just the typical ratios. Like we have camel stands for each category has one thing. C for capital adequacy, A for
I
asset
follow.
management.
So you cannot distinguish only between one variable. There may be some other variables like credit debit ratio or something. There may be many other parameters too. Yes or no? Hello, Sazal, please.
Yes,
There may be some other parameters, right?
Yes, sir. Like I have different ratios under each category, like capital adequacy ratio, debt equity ratio, return on assets, return on equity.
Followed. Now, please listen to me. In such type of problems, you can apply discriminant analysis. You can find out which factors are there which can discriminate between the small financial bank and the large financial bank, but which are the important factors which can discriminate. So you can go for the discriminant analysis. Tomorrow I'll be discussing factor analysis, and I will show you a number of examples where factor analysis is useful.
Sir, but
for your data,
I'm not doing any comparison. It's just that I'm only working, like I'm doing camel ratio analysis of small finance banks, just the ratios.
But you can do a lot of statistical analysis also.
Okay. Yeah, yes, that is what I'm asking. Like, can I do any statistical analysis with these ratios only?
Discriminant analysis you can do, and that will find out that which factors are there which can discriminate between these two categories.
Okay, sir. Okay.
Yeah. Yes, please. Any other question? Anyone? Aishwarya Sharma or Aprajita? Yes, please. Aprajita, you want to say something? Soma? Anyone? Any question? No question?
Yeah. Sir, can you hear me?
Yeah, I can hear you. Yes, please.
So, actually, in this course, you have learned a bit about the normality test.
Actually, your voice is breaking and it is not very clear. Can you just come closer to your mic so that?
Yeah. Can you hear me clearly?
I think unable to follow anything. Can you write in the chat box? Can you just write down in the chat box? Anybody else, please? Anyone else? If you have questions.
Sir, can you hear me now?
Yes, I can hear. Yes, now you can.
Actually, I wanted to just check. This is small information I just thought. We actually learned a bit of normality test with the distribution using this software in this course only. So as when you mentioned about the skewness test, I think, using the software, we have done this normality test.
There is a normal.
I just want to check with you, is it the same thing? Like
No. Listen to me, please. There are powerful tests, and there are two important powerful tests to check the normality of the test. One is called the Spirovilk test. Or another one is which is called KM test, Kolmogorov-Seminar test. These two tests can check the normality of the data, right? But if somebody is not aware of these tests, then you simply looking at skewness and kurtosis values, you can look at whether we have to go for the parametric test or the non-parametric test. Of course, KM test, Kolmogorov-Seminar test, KS test, and Spirovilk test, they are more powerful. But roughly, that's why I use the term rule of thumb. Rule of thumb says that if your skewness and kurtosis value, they lie between -2 to +2, still you can apply parametric test. Otherwise, you have to apply non-parametric test. But there are powerful tests also, KS test and Spirovilk test. They are given in SPSS. Okay.
Thank you very much.
Yeah. Any other question? Vidyasagar ji.
Sir, no query, sir. You can
Okay.
go. We will ask you last after you can finish, sir.
Okay. Yeah, please. Any other question? No question. So 23 of you are present. Please. मैंने आपको कोई ऐसा भी है जिसको हिंदी समझ नहीं आता? सबको आता है?
Yes, sir. We will understand.
Okay. नहीं, अगर नहीं भी आता कोई बात नहीं. I'll not use even a single word. But what I'm trying to say, because now I will start with SPSS after 5 minutes. I'll give you 5 minutes of break because you can go to washroom or you can take a cup of tea with you, right? And then I'll start with SPSS, how to enter data in SPSS, how to label, how to make different categories. So next half an hour will be very, very important. And then in the next 1 hour, what I'll do, in next 45 minutes, I'll cover up the correlation and regression part, which is a very, very important part. And then we will finish up around 8:30 because time is from 6 to 8:30, right? So we can have a break of 5 minutes, and you can, if you have any question or query, you can ask me even after the break. Otherwise, I'll start with SPSS. Will that be okay? Yes, please.
Yes, sir. Sure, sir. Okay.
Okay. So we can have a break of 5 minutes, and then I'll be back. Okay. And don't go anywhere, please. Otherwise, you will lose something. Don't go anywhere, and don't just mute yourself, and you can leave maybe and come back in 5 minutes. Yes, please. I am back now. If you have any question, any query, anyone want to ask something?
No query, sir. But sir, how to use which type of the question data table and according to objective, how to use which type of objective, which type of data, and how to use the SPSS. That is very important because we are novice learner, first time using SPSS. We
Yeah,
have
okay. I will teach you.
which method, which type of use the SPSS.
Yeah. I'm coming to that part only now. Some basics have been covered. Now I'll come to this part only. Should we start with the presentation?
Sure, sir.
Yes, sir.
Yes.
There were 23 earlier. Now we have only 19. Some people just wait for 1 minute. Maybe they'll join. I will start with SPSS, how to enter data in SPSS. Everything I'll make it in half an hour, and then half an hour for the rest of the half an hour, maybe 35 minutes for correlation and the simple correlation and simple regression. Two things we'll cover today. And tomorrow I'll be doing this multiple regression analysis, problem with multicollinearity, how to check multicollinearity, how to check autocorrelation, and also factor analysis. So tomorrow those topics will be covered. All right. So let me share the screen now. Is the desktop visible? Anybody? Is it okay?
Sir. Yeah, it is.
Okay. Now, if you are attentive, please try to understand the basics of SPSS. This is the logo of SPSS, you can see. And if you click this, whatever the version you are using, then IBM, now this is called IBM SPSS Statistics. It is no longer a statistical package for social sciences. So please remember, whenever you want to mention, always mention this, IBM SPSS Statistics. And in bracket, you can write the version 22, 25, whatever you are using. Doesn't have. Press OK. Sorry, you have to press cancel actually. So you will be, this is called the worksheet of SPSS. It is very much similar to that of Excel, right? In Excel, if you remember, you have in Excel rows and columns, here also rows and columns. So there are two ways to enter the data in SPSS. One is you can enter the data straight away, just like we do in Excel. Another is we can import the data from some other file like Excel also. I'll do it both the ways. Let's say I enter some values. Just randomly I'm entering some values. So I entered some values like 15 values. Okay. Now you can see by default, it has given the name variable, then 4 zeros and 1. If you start with the second variable, it will give you variable 402, variable 403. It will continue like this. How many variables you can enter? More than 57,000 variables you can enter. 57,000. So don't worry at all, right? But it's, let's say these are the scores of the students, say out of 100. Suppose these are the scores of the students out of 100. Okay. Then I can actually, its name should be score. So there are two views here. One is called the data view, another is called the variable view. You go to the variable view and change its name from here. Say score. All right. And then you come back. Now you can see the actual name is appearing. The actual name is appearing. So you can always go to the variable name, replace its name. Let's say next is age, you can replace with age. Next is height, weight, blood pressure, whatever. So this is how you can enter the data in SPSS, right? Now, it is not necessary whenever we start entering the data with some numeric value, see 12 is numeric, SPSS automatically understands that this is a numeric variable. Let me just repeat. If you start with some numeric figure, SPSS automatically understand that this is a numeric variable. All right. But If your variable may be address, it could be name, or it could be imply code, not necessarily numeric. So if it is not numeric, then this kind of variable which is not numeric, it is in terms of alphabets, then this is called string variable in SPSS. So you can also enter string variable. For example, let's say first is a male, second one is a female. Now you can see a beep. There is a beep here. You can see the beep. Why this beep is coming? You see, because it has accepted male easily, but it is not accepting female. Reason. The reason is, if you go to the variable view and look at the width of the numeric variable, it was 8. But what is the width of a string variable? String variable is not numeric, like male, female is not numeric, right? It is 4. And you can see male is having 4 words, but female is having 6 words. So it is not accepting. That's why it is giving you a beep. But you have an always option to increase the width. So this icon will appear. You can increase the width this to 8 or 80, whatever you want, right? You can increase this. And then come back, and then you can write here LE. Now you can see it is accepting. Female is accepted because you have increased. All right. So these things are important in SPSS. Now it is very difficult to enter male and female every time. Suppose I give you 5,000 observations to enter, and in front of each observation scores are given, and then you have to write down male, female, male, female. Very difficult. But I can always choose a code. Let's say 1 for male and 2 for female. So in next, suppose I choose this code, 1 for male, 2 for female. Now some of them may be 2, some of them may be 1, something like this. Your data may be like this. 1 means male, 2 means female. Your data is like this. Okay. And then you have 1 and 2, 1 and 2. Let's say 1 stand for male and 2 stand for female. But how SPSS will come to know that 1 is male and 2 is female? Then there is a value label switch here. You go to the variable view, and this is variable number 3 where you have put in 1 and 2. So go to under values, there is a values you can assign. Let's say your value 1, give the label that it is for male, add. And then 2 is for female. You can add female. You can add. 1 is male and 2 is female. Press OK, and you come back to the data view. Nothing has happened here, but there is a value label switch which can convert your alphabet to numeric, numeric to alphabets. This is called value labels. This symbol will appear. If you click this, 1 is male and 2 is female, right? Hopefully this part is clear to you, that you just enter the code, and code you can give the proper label under values. You come to the values, 1 is male and 2 is female. Press OK, and now you will be here. Now you don't require the variable number 2. You do not require variable number 2. If you don't require any variable, you click at the top, then this entire column will become yellow, and then right click and then cut or delete. This will go out of the picture. Now what is this variable? This is gender, so you can replace this by gender. All right. So you entered now 2 variables. One is score, another is gender. And if you want to see what is code, so 1 is male and 2 is female. Now what happens if you are not giving the labels? Your analysis will appear that how many males are there, how many females are there in terms of 1 and 2. It will give you the answer table, how many 1s are there, how many 2s are there. But later on you may forget what is 1, what is 2. But if you assign a proper label, now your table will appear that how many males are there and how many females are there. So readability will improve, right? Now sometimes our problem is to divide this data into certain parts. Let's say these are the scores of 15 students. I want to make 3 categories of this. Those students who have scored, say, less than or equal to 35 marks, and those who have scored between 35 to 60, and those who have scored more than 60. You can note down the categories. Those students who have scored less than or equal to 35, let's say give this code as 1. So less than or equal to 35, next column you can write code as 1. The next is 35-60. That means those who are between 35 to 60 dash column 2. That means code number 2. And more than greater than 60, code number 3. So let's divide this data into 3 equal parts, or not equal parts. There may be any other parts, right? So how to do this? So there is a transform here. Command is called transform. Transforms, you want to transform this variable. Now use this transform, and there are 2 things here: recode into same variable, recode into different variable. Okay. Now press on to recode into different variable always. Why? Because if you press on to recode into same variable, then you will lose the original data, and entire data, wherever there is less than or equal to 35, values will be replaced by 1, 35 to 60 by 2, and more than 60 by 3, and you will lose your original data. But I want to retain original variable and want to generate another variable, let's say score code, and score code will always be generated next to the variable which is empty, next to the cell or the column which is empty. So here it will be generated. So go to transform, recode into different variable. So whenever you start doing any operation or any analysis in SPSS, 2 windows will always appear. Always. This is called left hand window. This is called right hand window. And you can move this window anywhere. If you press at this, it will not move. You have to press at the top. You can shift it anywhere. Let's say I want to see this. Sometimes it appears here also, but you can move it here so that you can see the variables, or you can move down if it is somewhere it is appearing here, right? So now left hand window will always show you the variables which you have entered. How many variables we have entered? 1 variable and 2 variables. So it is showing 2. If you have entered 50 variables, it will show you a list of all the 50 here on the left hand window. At a time, maybe you can see only 20. Then this type of button will automatically appear. Scroll button will automatically appear. And if you click onto this, the next 21st variable will appear. Next 22nd variable will appear, so that you can see all the 50. Then what is the use of right hand window? Right hand window, you shift only those variable to the right hand window. Let me just repeat. You shift only those variable to the right hand window on which we want to perform analysis. Now we want to perform analysis on score only, not on gender. So I'll shift this score on this side. Now it is asking, where do you want to, what is your output variable? I want to make 3 categories of this. So I will give the name like score, let's say underscore code, score code. You cannot write score, then gap and code. That is not allowed. Dash is also not allowed. Any symbol, which is the special characters, are not allowed, like ampersand sign, like dash, hash, percentage. They are not allowed in the variable name, but underscore is allowed. Then don't forget to press this change. And here it is now appearing, score code. And here you, if you want to give, you can give the proper name, score code. Label you can assign them, so that you can easily understand that this thing stands for this. Now what we want to do, we have to replace just the old values with the new one. What are the old values? If it is less than or equal to 35, we will write that code as 1. If it is between 35 to 60, we'll write code as 2. If it is more than 60, we write code as 3. So go to old and new values. If you go to old and new values, you see there is a range here. This is up to the lowest point. This is highest and above. So in our case, there are 3 categories: up to lowest point, which is 35. Then highest and above is also there, more than 60. And there is a range also, 35 to 60. So if there is a range, you can make use of this, that 35 to 60. But if there is any cutoff in terms of less than or greater than, then you have to make use of this. So first we will make use of this up to 35, up to value, up to code number 1, and add this. So lowest through 35 will be given code as 1. Now next is between 35 to 60, that is range. So I will click on to range, 35, go up to 60, and give the new value as 2. Add here. And the next value is more than 60. So more than 60 highest, up to highest and above. So I should write here 60. And the code given is 3. If you have more codes, you can take, let's say I want 60 to 80 next category. So you can again plus on to range 60, 80, press 3 here, it will go to 3. The next is more than 80, so you can click onto this and more than 80 will go here. Now you can see 3 categories. Now you must be wondering that 35 is appearing under 1 also and 35 is appearing under 2 also. If there is exact value 35, will it be counted under 1 or 2? Let me tell you, there is no overlapping in SPSS. Let me just repeat. There is no overlapping in SPSS. Wherever you specify your value for the first time, let me just repeat. Wherever you are specify your values for the first time, every value up to that point is taken care of. For example, we have assigned 35 for the first time under 1. So that means up to 35 is covered under category 1. Up to 35, including 35. Remember this thing. Although 35 is appearing here, but up to 35 is covered under 1. So it will start from 35.00 onwards. 35 will come under 1 only because that was first time in under 1. Hopefully the things are clear to you. There is no overlap. Even if I start from 32 or you start from 30, again it will start from 35.00 because up to 35 is already taken care of by 1. So it will automatically start from 35.0 onwards. Okay, no overlapping in SPSS. Similarly, 60 is appearing first time under 2. So that means this will start from 60 greater than 60 or 60.00 onwards. Hopefully things are clear. Then press continue and press OK. And if you press OK, you can see another category is there. You can see 12 belongs to this, less than 35. 22 belongs to this. 44 belongs to between 35 to 60. And now you can give the labels same way as we have done for male and female. Let's go to label and give this labels so that you can understand that 1 stands for what? 1 stands for less than or equal to 35. 2 stands for between 35 to 60. And 3 stands for greater than 60. You can assign labels. And then press OK and then come back and you will see, if you press this, you can see the proper table. So your table that will appear will show you this thing only. That will show you this thing, that less than or equal to 35, all these values you can see. 35 to 60, greater than 60. So anyhow, you can have been able to make 3 categories. Hopefully the things are clear to you. Otherwise, I will send you a link also. Now, please remember there is a YouTube, मेरा एक YouTube video है. You can just write down in the Google statistical techniques using SPSS. You can note down please, statistical techniques using SPSS by Dr. Suresh K. Sharma or Suresh Kumar Sharma. And you will see a YouTube video. And if you forget any one of these steps, they are clearly given in those steps. So you can click on to pause button and learn from there, right? So if you want me to send the link, I can send the link also, right? But if you search, Google search with my name, statistical techniques using SPSS by Suresh K. Sharma, it will appear. All right. That will make the things easier. Now coming back to the variable view. For example, under gender, you see, if you gender, it will always take 2 decimals. By default, SPSS will always give you two decimals, whether it is categorical data or it's measurable quantities. But if you don't require, for example, gender 1 and 2, we don't require any decimals. So decimals you can eliminate. Decimal for gender, you can write 0. Similarly, for score code, I can write 0. And if you write 0, there is no decimals now, right? Because don't require this thing. Next. Now, it is not necessary that you always enter numeric variable. There are other options too. You can enter with comma. Now, why this comma option has been given? For example, I want to enter salaries, say 45,560. 54,690. And generally we assign comma after every 2. So if I fix the width after 2 and decimal 0 and press OK, then you just need to enter 4, 5, 6, 6, 7. So you will see right from the left hand side, after every 2 it will start assigning the comma. But if you use comma yourself, from your keyboard, then it will no longer be a numeric variable, because SPSS doesn't understand comma, that it is a numeric variable. So use the proper format, and then when you add all the salaries, then it will appear with comma if you are using proper format. And in many countries, comma is not used, dot is used. So you can use dot also instead of comma. For example, 35,444. And after every 2, if I want to assign comma, so I'll write 35, then 44 comma. So people in many countries, they write 34 dot. So they use this symbol also. So that's up to you. Then scientific notation. Scientific notation means, let's say 1000. 1000 means 10 into 10 into 10, means 10 raised to power 3. And in scientific notation, 10 raised to power 3 is written as capital E03. Capital E03. That means this is capital E stands for 10. 10 raised to power 3. If it is somewhere written in the output that your output is capital E minus 02. So what is the meaning of this? This means it is 10 raised to power minus 2. Right? So you can use scientific notation, and most of the engineers, they write scientific notation. Their results in scientific notation. But generally in social sciences, we don't require. Next is a date variable. And in date format, there are a lot of choices. For example, India, we write day first, then month, and then year. If you go to US, they will write month first, then day, and then year. Right? So you have to choose the proper format. Now, if you write down, let's say today's date is 14th. If I want to enter today's date, and suppose I start entering 14, then dot, then 05, then dot 2021, and you start entering your data in the data column. SPSS doesn't understand anything. Why? Because 2 dots in a data are not allowed. So it will take this as decimals. But if you are using a proper format, then what you need to enter, you simply need to enter 14, then no dot, 1405, then 2021. This is what you need to enter. And then press enter, you go to the next column, and then this format automatically appear. Your date will show you that it is 14.05.2021 automatically. So choose the proper format and then start entering the date. Very powerful function. Then dollar doesn't mean much. That dollar sign gets attached with every figure. And string I have already explained. The rest of the things are not important. Right? Now, if you send me this file, you see how to save the file. Go to File, go to Save As, and then let's say I want to save this on desktop, and then give the file name, let's say workshop. I'll give the workshop, right, and press save. Then file with the name of workshop.save will appear on the desktop. Now, this is the extension of SPSS file. Please remember, extension of SPSS file. Just like we have extension of the Excel file, we have extension of the Word file, docs. Similarly, there is extension of SPSS file. And SPSS file will appear like this. This is one file, table.save. This is Dr. Rajan.save, corrected data.save. So these are all SPSS files. This type of symbol will appear. And this will open only. If I click onto this, Chandigarh 1 report will open. It will be an SPSS file, but open only if you have SPSS loaded on your computer. Okay. So this is how you can save the file. And now if you send me this file, then this was numeric actually. Come to numeric. All right. So what is this label actually? You can give a proper label, because if you send me this file, I don't know whether it is a score of physics, chemistry, management, no idea. So here you can give a proper label that these variable is concerned with the scores of the students. Scores of the students, right? So nothing will happen in data view. But whenever output will appear, then it will show you that this variable is concerning with the scores of the student. So readability will improve. Right? Okay. Now, then important part is measure here. If you remember, it is showing nominal, nominal, nominal. But our data is not nominal. What is score? Score is a continuous type of variable. So you must change this to scale. Next is gender. Gender is nominal. Correct. What about this? These categories. Less than or equal to 5, 35 to 60. These categories can be arranged in order. So obviously this cannot be nominal. This has to be ordinal. So that's why I discussed scales. Now, if you don't have knowledge about these scales, you will face difficulty under this measure. Because sometimes all of them are written scale, sometimes all of them are written ordinal, sometimes nominal. So you have to make a proper selection. Okay. So please remember all these things. Now we are completed with one part of the data. That how to enter, how to label variables. Now we'll come to how to basically select male and female data. Let's say this is gender. Suppose somebody is interested to perform analysis on only male or only on female. Then go to data, and there is an option here which is called select cases. Go to select cases, and then you can use this condition. If condition is satisfied, then that data will be selected, and if that condition doesn't satisfy, it will not be selected. Let's say I put condition on gender. So you click on to if, and then put gender. If gender is equal to this is acting as a calculator now. If gender is equal to 2, gender is equal to 2 means female. Then this is how you read. Select cases if gender is equal to 2. Means select cases if gender is equal to female. Then you will see only female will be selected out of this data. Continue, press OK. You come back to your data. Now wherever there is male, it is struck off. You can see there is a struck off. Now if you give any command here, if you give mean, median, mod, only female data will get analysis. There is no need to make a separate file of male and female. You will get results only for the female. And let's say I want for male, then again go to the data. Again go to select cases. Then change this condition. Instead of 1, instead of 2, you write down 1 and then continue. Press OK. Now you will see that females are struck off and male is retained. Now if you carry out the analysis will be done only for male data. Okay. And now if I want to select male and female, all the entire data again, then same thing. Go to data, go to select cases, and there is a first select all cases again. Select all cases again. Press OK, and then you will see that your filter is removed, and this filter you can delete. Now you have the entire data with you. So this is how you can select the cases, right? Because somebody may be interested to do the analysis only those who have very high scores, greater than 60. So you can select category number 3. You can select category number 1 if you want to find out which are the weaker students, right? And medium students 35 to 60 you can select. So these things are possible all in SPSS. Okay. All right. So these are some of the basics which I have explained you. And the last thing is about transformations. You can make transformations. Sometimes we need to make log transformation, sometimes exponential transformations. Let's say I want to transform this data in terms of log. Then go to transform, and there is an option compute variable. Compute variable. Let's say I go to compute variable. Then I want to take the log of this score. Then there are functions here. See, as I mentioned that most of the time SPSS will open at least 2 windows, but sometimes there may be more windows. Just like we have one window here, another window here, another one. So 4 or 5 windows has opened. Now log is an arithmetic function. If you click on to arithmetic, all the functions of arithmetic will appear here. This is absolute, sine inverse, tangent inverse, cos, exponential. This is log to the base 10. and I want to compute log to the base 10. So click onto this. What it will do, the entire description will appear here. That log to the will give you the log to the base 10 of the given number, and then shift it here. Now it says question mark, for which variable you want log 10? We want for score. Score is the only continuous variable here. So take this score on this side. Now log 10 of score. Now still OK is not appearing. It is not highlighted. Why? Because it is asking where do you want to store. Give the variable name. So let's say I give this variable as log underscore score. Right now OK is appearing. Press OK. And now you come back to the data and you will see that log of 12 is 1.08. Log of 22 is 1.34. Log to the base 10. So all the logs have been computed. This is how you can make transformations. You can subtract the two columns. You can multiply the two columns. Go to transform. Go to compute variable. Let's say I want to take a difference of two variables. Let's say this minus this. Although it doesn't have any meaning, but this minus this. Let's say I put this as difference, right? And then let's say score code minus gender. Although it has no meaning, just to give you demo. And then press OK, and now difference will be computed. You can see difference 1.08. And this is a difference of what? Just a minute. I think we have gone to transform, compute variable, score code minus gender. Oh, okay. We have subtracted this minus this. Score code minus gender. So 1 minus 1 will be 0. 1 minus 2 will be minus 1. You can see. You can see. I thought I was taking difference between this and this. Then it should be 0.08. So anyhow, it's correct. So no problem. You can multiply, you can divide all the variables. And if you don't require any variable, then what to do? Go to this, click and cut. Click and cut or delete, whatever. So this is how we can enter the data in SPSS. Simple things. Now, if you have any questions up to this, please ask me. Now I'll show you how to import the data from Excel to SPSS. Any question, please? Any question up to this? Anything which is not clear? Yes, please. You can unmute and ask me. Hello. No question? Everything is clear? If everything is clear, I can proceed further. Should I move on to? Yes, please. Yes, Sazalpreet, you want to say something?
Sir, no questions.
Okay. So now I'll show you how to import data from some other file like Excel. Okay. So I'm just closing this file, and you know how to save the file, labels, etc. Everything is known to you now. Just closing the file. And suppose there is a file here, Excel. You can open any Excel file. Suppose this is Excel file. So and how many observations are here? How many observations? It goes up to 71, but observations are 70. Why? Because first is the variable name. In first row, there is a variable name. Remember, please. So these are 70 observations, not 71. Okay. And you can write this as capital, doesn't matter. Or I think I'm using small only. Leave it. All right. Now, how to import this Excel file into SPSS? Please, you can note down 2-3 steps. Please note down 2-3 steps. Number one, use small letters in variable names. Always use small letters in variable names. So I have used only small letters: mutation, age, locality, sex, religion. Only small letters. First thing. Number two, no special characters are allowed in the variable name. No special characters are allowed in the variable names. What are the special characters? Ampersand sign, hash, dash, blank space. hyphen, they are not allowed in the variable name. Number 3, the most important. Number 3, any variable name should not start with numeric value. Any variable name should not start with numeric value. What does this mean? You cannot write, let's say this is 40 years of age data. I cannot write 40 age because first number is 40 and you cannot start the variable name with a numeric. Of course, you can write age 40. That's okay. That's okay. Because it has to start with any character, not numeric. If you cannot write 4 age, no, not acceptable by SPSS. So keeping all these points in mind, and remember its path, it is on the desktop. We will import this file into SPSS, and there are 70 observations I have shown you. And please remember, whenever we start with SPSS, sorry, Excel, there are sheet 1, sheet 2, sheet 3. But if you have data in sheet 2 and sheet 3 also, SPSS will import only one sheet, whichever you want. If you click onto sheet 2, sheet 2 will be imported. If you click onto sheet 3 will be imported. But SPSS will import only one sheet at a time. Remember. Now I'm closing this file. It's on the desktop. What happens? It's not coming down. Okay. Let me shift it here. Let me close this file. Okay. So it is here on the desktop, test 1, and we will import this file into SPSS. Let me just open SPSS again. Just give me a minute. Press cancel. And now we have to import the file. How to import the file? Please note down the steps. File, open. After file, there is open. Go to data. Ours is a data file. Then it was on the desktop. Give the proper path, desktop. Then file of the type is Excel. Now Excel is appearing here. And our file name is test1. That was now automatically name will appear. Now press open. It will ask you one question. And the question is this one. Read variable names from the first row of the data. If you remember, in first row of the data, there was mutation, age, locality. So by default, this option is on. And if you are using different sheets, then you can scroll down to the different sheets. If 15 sheets are there, so it very long list of 15 will appear here. You can scroll down to a particular sheet. But there is only one sheet, so it is appearing only one. And simply press OK. And your data will appear. Now your data is coming. You can check. It is mutation was the first variable, age, locality, sex, religion. It has been imported into SPSS. And how many observations were there? Check. 70. All 70 has been imported. All right. So this is how you can import any Excel file to SPSS. Okay. So with this background, I have shown you all basics of SPSS, and now I'll show you a simple analysis, and then we will move on to the correlation. And I'll come to theoretical part will be covered today, and practical part I'll try to cover tomorrow. Okay. I'm just opening some of the files which I have already saved in SPSS. Let's say one of the file is here, age and gender. I'll show you this file. It is saved in SPSS, and you can now recognize that all these are SPSS files. So this is the file. You can see. First variable is age, then there is a gender. You can see 1 is for male and 2 is for female. Then this is called age code. That means age has been divided into certain codes. This age has been divided. Let's see that. Go to the variable V and check from here what is age code. So age has been divided into different categories. 10 to 19 years of age, category number 1, 20 to 29, category number 2, right up to 60 to 69 with a gap of 10 years. So it is 6. So age has been divided into 6 categories, right? So I can check from the file. And male, female, 1 is for male and 2 is for female. Somebody can write 1 for female and 2 for female. Doesn't matter. So you should, right? So this is our file. Let's do some simple analysis. This is called univariate analysis. That is the first part of the lecture today. Univariate analysis. What is univariate? Univariate means you are dealing with a single variable. Let's say this is one variable, this is another variable, this is another variable. Our first aim is to go for the counting. So how the counting is done in SPSS? Go to analysis, go to descriptive, go to frequencies. And frequencies are obtained only generally for categorical data. And which are the categorical data here? If you see, this is categorical data. This is also categorical data. Age code 1, 2, 3, 4, 5, 6. So take this gender on this side, age code on this side, and it will display frequency table. Press OK, and you have the result in front of you. 169 observation. No observation is missing. There are 91 males, 78 females. This is their percentages. Then there is a column of valid percentage, which is same as percentage. And then there is cumulative percentage. Look at the next one, age code, because these two categorical variables were there. How many people are there between 10 to 19? 4. How many between 20 to 29? 66. Between 30 to 39? 47, and so on. Now there are two percentages. One is percent, another is valid percent. Now there is no change. There is no difference. Why? Valid percent and percent, they are same. Why? Because there is no missing value. If there would have been 1 or 2, then please remember you always have to see the valid percentage. Let's say out of 100 values, 2 values are missing. Then entire percentage will be computed out of 98. So valid percentage you have to take care if there are missing values. And if there are no missing values, valid percent and percentage will be same. Okay. And cumulative, you know, I think. For example, if somebody asks me this question, it is 2.4 plus 39.1 will be 41.4. Then you add the 2 and 27.8, you will get 69 and so on. Addition of the previous one. You will get the answer. This is called cumulative. What is the advantage? Advantage is if somebody asks me, what is the percentage of the people who are below the age of 39 or equal to the age of 39? Then I'll just look for this percentage. So 69.2% of the people are below the age of or equal to the age of 39. आपके डाटा में 39 से छोटे जो लोग हैं उनकी percentage 69.2% है. So that can be answered with the help of the cumulative percentage. So very simple analysis, right? From where we did, go to analysis, go to descriptive, go to frequencies. Okay. Now because this is a continuous variable, let's do the mean, SD, etc. for this variable. Mean, SD, etc. So go to analysis, go to again descriptive, again go to frequencies and take these two variables outside. And take this age here. Now, do we require to compute frequency table for age? Frequency tables are required for categorical data, not for continuous data. Age is a continuous variable. You remember? We don't require frequency table. Otherwise, a very big table will appear. 18 is appearing 1 time, 22 is appearing 2 times, and so on. Doesn't make any sense, right? So switch off this option. Once you switch off this option, SPSS will give you a warning. You see, it has given you a warning that you have turned off the frequency distribution table. Okay, no problem. The next is statistics. What do you want to compute? Go to statistics. Let's say I want to compute mean, median, mod, skewness, kurtosis, minimum value, maximum value, standard deviation, variance. Then you can compute quartiles also, percentiles. Let's say I'm interested into 23rd percentile. I'm interested into 78th percentile. I'm interested into 95th percentile. So whatever you click, that will appear. So press continue and press OK. The answer, अभी click भी नहीं करेंगे, answer आ जाएगा. ये देखिए. 169 observation, missing value 0. Mean age is in your data is 34.30. Median is 31. Mod is 26. Standard deviation is 10 point this. And if you square the standard deviation, you will get variance 106. Square of 10.3 to 8 will be 106.676. Now this is your skewness. This is beta 1. Kurtosis is beta 2. Now look at beta 1. I told you that if beta 1 value is positive, then it is positively skewed. So it says that your data is positively skewed because this value is positive. What about kurtosis? Kurtosis is coming out to be negative. Beta 2 is less than 0. If it is less than 0, then your curve will be platykurtic. Platykurtic means flatter than the normal curve because beta 2 is less than 0. But remember, I also told you that if beta 1 and beta 2, they are between -2 to +2, then your data is approximately normal, and you can check. They are between -2 to +2. This is also and this is also. So that means this data is approximately normally distributed, right? That's a rule of thumb. Although we can check the exact normality of the data using KS test or using Sparrowville test. All right. Then minimum value is 18, maximum value is 63. Then your percentiles. Now, please remember there is a difference between percentage and percentile. Percentage is always computed out of 100%. But percentiles will give you cutoff point. For example, 50th percentile. 50th percentile means half of the observation. Half of the observation means median. So 50th percentile will be same as median. So median is 31. 50th percentile is also 31. What is 25th percentile? This is the first quartile of your data. That means 25% of the observations are below the age of or equal to the age of 26. This is what the interpretation is. Then Q3 is called third quartile. 42% of the people, sorry, 75% of the people are below or equal to the age of 42. Only 25% are above 42 years of age. Look at 95th percentile. What is cutoff? 53. That means in your entire data, 95% of the people are below the age of 53 or maximum up to 53. Or alternatively, what you can say, that 5% of the people are there whose age is more than 53. This is what it means, right? So I have given you the entire interpretation. And then let's say I want to do analysis only for female data. You know the selection procedure. So go to data, go to select cases, use the if condition. If gender or sex is equal to, let's say 2, then you can see press OK. Only data related to female is selected. Male is struck off. And if you give any command now, only analysis of the female will be carried out. Let's do analysis, descriptive, frequencies, and now say age. Everything is there. You see, you can click on to range also. They are same. Continue, press OK, and you can see analysis is only for female data. There were 78 females. There were 78 females in your data, right? I have shown you earlier also. So this entire data is for analysis is for female. Similarly, you can carry out for male. All right, you can carry out for female. And if you want for all, again, go to data, go to select cases, select all the cases again. All the cases will be selected again, and you will be back to this. So very simple analysis. This is called univariate analysis. Univariate analysis. And now I'll show you 1 or 2 graphs, because graph features are very powerful in Spss. You can multiple bar, you can draw pie charts. All these graphs are possible. That is for generally drawn for univariate data. Go to graphs, go to legacy dialog. Let's say I want a bar graph. Let's say simple bar diagram. Simple bar diagram for age code, let's say. Define. Your category axis is suppose age code. Just drag and drop. When you have to drop, just drag from here. Now you can see hand is appearing. and do not leave unless you come to this and hand appears again. When hand appears, then you leave it. And it will give you bar diagram. You see, it will give you a bar diagram. This is a bar diagram. First stage 10 to 19, 20 to 29, and so on. And if you do any editing in SPSS, please remember, you cannot edit this graph here unless you double click. You see what is written, double click to activate. If you double click, you will come to what is called chart editor. That means you can edit your chart. This should appear. Double click, you will come to chart editor. Then place your cursor at any point. Let's say I don't like this color. Then you can go to fill and border. And let's say I want this color. So every color will be replaced with this. If you want yellow color will be replaced. If you want any other color will be replaced. Let's say you can change the color of even one bar. Let's say this bar is very important for you. You want to change the color of this. So what to do? Mark here. You can see a border around. Then place your cursor here. Right click and select this bar. Now you can see border around this bar only. No other bar. And let's say I make this blue. Then you can change the color of this bar. Similarly, you can change the color of any other bar. Right? And then I can also, let's say instead of age code, I simply want to write down, suppose, age here. So you can write down age. And let's say this, if you mark here, you can change the style. Let's say I want this as bold and the font little bit I want to increase. And now it is appearing in a good form. Similarly, let's say instead of count, I want to write down frequency. So change this to frequency. Right? And let's say this is a gap of 20. I need a gap of 5 so that you can read properly. So you go to scale. This is a gap of 20. So I can make this 5. Apply and you can see. And then you can go to text style, make this bold, make this a 9 and apply. And you can see very, very clear picture now. Then you can add titles also in options. So there is a title. Let's say I want to add here a title, say bar diagram. So you added the title. Okay. Then you have to go to elements. And in elements, let's say show data labels. So it will show you how many values are in each. So 66 is a figure here. This is the maximum one. But you have an option. This is appearing in the center. You can make it at the top or the bottom. So how? Go to custom. And this is the top, this is bottom, and this is center. This is by default. It's in the center. If I want to shift it to the top, so apply. And it will show you at the top. And if it is not readable, you can change again to this as a bold and make this 9. So you can read it very clearly. Now you can see. Okay. So all the options are there. All the options are there. And you can write something in between also. How you can write? Go to options and go to use the text box. Let's say I take the text box and write down here significant bar, that this is the most significant bar. And then you see, mark here quickly and take this here. You can see. And you can adjust. According to your space, you can adjust. Slightly more. Now, your graph is complete. Yes, please. Any questions?
Sir, can you please repeat the part where you actually put up the values on the bar graphs, the highest values?
This one. This one.
Yes, sir. Yes, sir.
Okay. So let me just delete this. Now it is out of order, right? It's deleted. Now you go to options, and in options, you go to elements. So just mark here, long border, then go to elements, and in elements you have show data labels. Now you can see data labels are appearing. Is this okay?
Yes, sir.
Yes. Now, once your graph is complete, you just click here, and now you can see your final graph is here. Now you can take this graph anywhere. Suppose I want to paste this in Word, just copy from here, open your Word file, and paste it here. Now this will be, and now you cannot make any changes here, but only thing is you can reduce space. If your space is less, so you can reduce the space depending upon which type of space you are available. So you can reduce the space. If this much space, you can reduce it. You follow my point, right? So this is how you can draw the graph. One or two more graphs, and then I'll come up to the next one. Let's say I want to draw multiple bar diagram. Bar, then cluster bar diagram. I'll be a little bit fast now. Category X is, let's say, age. This cluster by say gender. And then you can add titles later on. And this you can see clustered bar diagram, where this is the green color for female and blue color for male. You can check that, right? Similarly, you can double click, then you can add elements, data labels, you can add titles, and all these things are same. You just need to practice. Then you go to, let's say, you can draw 3D bar also. How to draw 3-dimensional pictures? 3-dimension means, let's say this is your x-axis category, and z-axis category is, suppose this, and then press OK, and you will get the 3-dimensional picture. You see, this is for female and this is for male. All right. So 3-dimensional pictures are also possible, and they are quite good in SPSS. One or two more graphs. Go to pie diagram, and let's say pie diagram define slices by, let's say, age code. Press OK, and you will see a nice pie diagram. Double click, and then go to elements, go to data labels. This will show you all the percentages. And if you want percentages outside, you can mark this outside, and you can see all the percentages appears outside. And from here itself, you can go to the other options like 3D. Let's say I want 3D. You can click onto 3-dimensional and click onto this angle also. It's up to you. Where do you want the picture to be? And press OK, and you can see a 3-dimensional. Then you can also have the exploded slice. This is exploded. And if you don't want exploded, again click, you will get the complete. Then your first angle. So first slice is always placed at 12 o'clock. Let's say I want the first slice to be at 3 o'clock. Then you change from here. First slice at 3 o'clock. So it will shift to 3 o'clock. If you want at 9 o'clock, it will shift to 9 o'clock. So many options are there. If you want with shadow, so it will be 3-dimensional with shadow. You see, with shadow. So many options are there. You can add titles from here, options, titles. Here you can write pie diagram. Pie diagram. And now this is complete. Then you copy from here and paste it in Word. You go to Word and paste it somewhere here. So second picture. So you can draw as many. How many you can draw? You see, I'll show you. There is a bar diagram, 3D we have drawn, line diagram, area charts, pie charts, box plot, error bar. There are many. Histogram. Let's say I want to draw histogram for this age. For age along with the normal probability curve. So this is the histogram for age. So everything is fast, right? So you can see this is a normal curve. If your data would have been normal, all the bars, they should have been within this curve, but they are outside the curve. So you can see data is not normally distributed, basically. It says data is not normally distributed. Okay. And you can also check. This is with the help of histogram. And you can also check using Sparrow-Wilk test. How you to apply Sparrow-Wilk test? Let's say go to data. Go to descriptives under, I think it's under explore. Under plots, you have the histogram and then normality plots with the test. So I'm checking the normality of age using Sparrow-Wilk and this test. Continue and press OK. And you will see both these tests are appearing. This is the result of the KS test. This is parabolic test, and both of them are significant. P value is less than 0.05. That means the data is not normally distributed. Similarly, the same thing is shown in the histogram too. We have already seen that it is not normally distributed. So you can apply test. So this is what I wanted to tell you, that this is univariate analysis. All I have done today is univariate analysis, and I think we will move on to the bivariate analysis tomorrow only. Tomorrow we have enough time. In the first part, I will cover the correlation part, then some part of regression also. And in the second part, we will do the factor analysis. Yes, please. Any questions? I'm just giving you 5 minutes for question answer before I wind up. Any question? Yes, please. Any question you want to ask? No question? Aparajita ji, Vidya ji, anyone want to ask any question? Saha Saab?
No question, sir. Most probably they have understood.
Let me see any question in the chat box. There is no question in the chat box also. That is something strange.
Sir,
Yeah,
I
sir.
don't have a question, but I have a suggestion or something I just want to ask you. Is it possible that the exercises which you are going to explain tomorrow, we can get to use 1 or 2 applications using the software itself? Is it possible while your sessions are going on?
You have SPSS?
No, sir. We can download the trial version.
You can download the trial version. You can
If-
download the trial
if-
version, but only problem will be because some of them may not be keeping pace with me, and you can note down the steps in the meantime. I'll go slow a little bit. You can note down the steps, and if you have any question and query, I can repeat all the steps again.
Okay, sir.
You try to do with me. You try to do with me. If you able to do it, fine, because there will be other people also, na?
Yeah.
Some of them may be slow, some of them may be fast. Because generally, what happens when I come to Shantiniketan, then we have in which I trained the people for 4 days on SPSS. In the morning, we have the theory part. In the afternoon, the whole session is practical. Then we give them assignments actually. So there it is possible, but here on online, sometimes it becomes difficult because there is a connectivity issue. There are some problems. People don't listen to. So there are many other issues of that type. Yeah. But
Thank
if you
you.
have, I'll send you the data tomorrow and you can try to be with me. Yes.
Okay, sir. Thank you.
Yes, please. Any other question? Any other question? तो सर जाते जाते इनको कुछ सुना दिया जाए।
जी सर।
देखिए आज आप लोगों से पहली बार मुलाकात हुई है, कैसा लगा वैसे आपको? कुछ थोड़ा बहुत, कल हम और पढ़ेंगे बहुत।
जी सर।
How was the session? Anybody please?
Please give feedback.
How was the
Good
session?
evening, sir. Good evening.
Good evening. Yes, please.
Yes, the session was very
Okay.
sincere, and you showed it many times. So it was quite understandable, and I enjoyed it. But actually, what I feel is that if I could do it, then it would have been better. But anyhow, this will be recorded. We can go on seeing it again and again to follow the steps. Thank you,
Yes.
sir, for your valuable information
Okay.
and teaching
Now,
us.
yeah. और अब जाते जाते एक शेर सुन लीजिए जो आपके लिए लिखा गया है, पार्टिसिपेंट्स के लिए। तो शेर ऐसा है कि खूबसूरत सा एक पल किस्सा बन जाता है, खूबसूरत सा एक पल किस्सा बन जाता है, ना जाने कौन कहाँ जिंदगी का हिस्सा बन जाता है। कुछ खास लोग, यानी कि आपकी तरह कुछ खास लोग मिलते हैं जिंदगी में इस तरह, जिनसे ना कभी बिछड़ने वाला रिश्ता बन जाता है।
Great sir.
Great, sir. Great.
Very nice, sir.
तो आज का सेशन मेरे ख्याल से काफी है आपके लिए, और जाते जाते अगर कहो तो एक और शेर सुना देता हूँ।
जी सर, मैं तो बैठा हूँ इसलिए।
तो ये कि जिंदगी किसी की मोहताज नहीं होती। मैं थोड़ा उर्दू बोल रहा हूँ, सॉरी। मोहताज का मतलब होता है किसी की गुलाम नहीं होती, कि जिंदगी किसी की मोहताज नहीं होती, दोस्ती सिर्फ जज्बात नहीं होती, कुछ तो ख्याल आया होगा खुदा को, वरना आप सबकी हमसे आज मुलाकात नहीं होती।